Yeah, so for those who are joining us, I want us to look at this combined science trilogy. This is physics paper 2H. So we're going to have a walkthrough on different questions that have been asked in this paper and what's the best way to answer them. The first question, we're told that the sun emits continuous spectrum of electromagnetic waves. So something that we need to understand and appreciate is that electromagnetic waves is just a family of waves which are arranged in the order of increasing or decreasing wavelength or frequency. So in this case, when for instance, with this setup that we have here, as you move from the right to the left, you realize that what's happening here is that the frequency is increasing. So this is high frequency waves on this side, high frequency. And then here we have low frequency. So which means that A, we can identify it as radio waves. Yeah, A is basically radio waves. And then we are going to also identify the second wave that we are having here. This is basically microwaves. B is microwaves. And then we have C, which is denoted, or which we are going to identify as X-rays. So under this area, as you are preparing for your paper for AQA Physics Paper 2, what I want you to remember is that you must understand the order of these waves, so that at least when one is missing, you can be able to tell. You need also to remember other aspects like the properties of each of the common properties of all these waves that we are talking about here. So which will mean that in this case, if in the event you are asked a question, whereby you are supposed to identify the type of missing wave, you are able to do. Also, you need to remember that so you need also to identify the common properties. I've said all the waves are transverse in nature. All these waves, they travel at the speed of light. All these waves, they obey the wave equation. So those are the key important you are going to look at. This is DEG flu. DEG flu, are you going to do a DEXEL IGCSE? A DEXEL IGCSE, I'll be able to do it tonight once I'm done with this live that we are having for AQA. So we shall have a DEXEL in the evening. So purpose to join, right? So need also to mention that these waves, they obey the wave equation. So you are asked here similar properties, one similarity and one difference between properties of ultraviolet waves and gamma rays. The similarity is that both travels at the speed of light in a vacuum. In a vacuum, and the speed at which they travel, basically there we are going to say that they travel the speed of light, which is 3 × 10⁻⁸ meters per second. So you need to remember a few properties like they obey the wave equation, they can be reflected, can be deflected, and so forth. We need also to remember the difference between the two waves, and one of the difference that exists between the two waves is that these two waves are, of course, they are electromagnetic, but one has a greater wavelength than the other. So we're going to say gamma rays have higher frequency than ultraviolet So that is what you need to remember as far as electromagnetic waves concerned. So you need also to remember the uses of each of the waves, and also you need to remember the harmful effects of each of the waves. For instance, uses, we can talk of X-rays. They are used in medical fields to take radiographs, and also to used in industries in order to check the fractures of metals, right? We can talk of also X-rays or gamma rays used in medical field to treat cancer, and also they can be used as to preserve food, because gamma rays, they can be able to kill germs, and this can keep maintain food. We can talk of infrared, which can be used for cooking food, radio waves used for communication, microwaves used also in satellite communication. Then harmful effects, we're going to talk issue like skin cancer from ultraviolet. We can talk of X-rays and gamma rays, which can be able to cause cancer. And then we can talk of skin burns, which can be caused by infrared radiations. So basically that is what you need to remember. And then we have another aspect here, what's the name given to this process, and in this case we are going to say this is called diffraction. This is called, this question number 3, this is called refraction. Yeah, this is refraction. And in this case, you have to remember this is dispersion of light, whereby light is separated to its constituent colors, because each of the colors have got has got different value of refractive index. So once you've remembered that, then let's see what is the next question asking us to identify. Write down the equation that links frequency, and this is what I was mentioning about, and this is what is called the wave equation. And the wave equation is equals to, you have to write it in full. You need to say this is wave speed, which is going to be equals to what? Equals to the frequency times the wavelength now. Yeah, so wavelength. And upon knowing how this formula state, you need also to know how you can be able to use it. You need to know how you can be able to use this, right? So, which means that since in this equation we are given the speed of light at this given point, and then also you are given yeah, we have the speed of light, we have the wavelength, then we were supposed to calculate the frequency of this wave. So basically we are going to rearrange this equation and say V is equals to F lambda, and then if we rearrange it, it will be frequency is going to be equivalent to what? Is going to be equivalent to V over lambda. Yeah, so in that case we are going to say, and let me just tell you this is going to be 3 times 10 raised to power 8, and we shall divide that by 5.0 times 10 raised to power negative 7. So if we work it out, we are going to put that in our calculator so that we can be able to check what the answer is going to become. Yeah, so I need to put that in the calc so that we can be able to check what our answer should be. Of course, we need our calculator there. We need our calculator there so that we can be able to work it out. Which is going to be what? Our calc is there. Yeah, so we are going to put in whatever we have in the calculator so that into the calculator so that we can be able to get what the answer is here. So we are having the fraction part, and then we shall say 3 times 10 raised to power 8, and if we just move it down, and then this is going to be 5.0 times 5.0 10 raised to power, if you work it out, you're going to get 10 raised to power negative 7. So yes, just talk here, times 10 raised to power negative 7, and if you work it out, you're gonna get your answer equivalent to 6 times 10 raised to power 14. So that becomes our answer in this case. No, stop making noise. 6 times 10 raised to power 14 as the final answer in that case. So we shall just transfer our answer down here so that we can be able to get our mark just to make the exam. Let's go. Rose, hebu tembeza mtoto. Tembeza mtoto.
Rose, ma huyu.
Chukua mtoto nje mcheze.
Nilitoka lunch. Nimetoka lunch.
All right, so basically that is exactly what we are supposed to do in this case. Yeah, so yeah, and we are just having a live, guys. Kindly just like the live and also comment, and let me know whether you are following through and you are getting value from this particular video that I'm doing here. So we need to move further. We need to move to the next part. Here we have just worked about electromagnetic waves. I need us to move to the next part. The next question that is asked here, let's see, a student investigated how the acceleration of a trolley is affected by the force acting on the trolley, and show some equipment used. We have a trolley, and then we have a runway, and then describe the method the student could use, and then you could also include extra equipment that you may require in order to work out this particular investigation. But what is the investigation all about? The investigation is about how acceleration is affected by the force acting here. So something that we really ought to put into consideration here is that we need to identify how the force is going to be varied, right? So one of the things that's going to happen, we need a force that is going to make this trolley to run down. So what I will do, or what the student need to do, is to come up with a pulley somewhere here. Then we are going to have just a pulley at that given point, which is going to pull, and then we shall have a string that is going to pull this a little bit down. Let me just reduce this so that we can be able to have this well articulated here. So I'm going to reduce a little bit this so that I have my pulley there, and then I'll pull this down. It will run through this given point, and once that has run down like that, then we shall have our pulley somewhere there, right? The string running down like that. Yeah, so then we're going to hang different masses in this other end here. So we are going to hang different masses here. Of course, we keep on adding the mass or increasing the mass under this particular section. Yeah, you shall add a mass there. Then also you keep on increasing the masses as you observe how long it takes the trolley to run down the runway. Yeah, how are you going to detect, or how are you going to determine the time taken in this case? Of course, which means that in order to explain this, we're going to say that okay, let us just label the parts first, guys. Like the live, these are what we call slotted masses. Slotted mass. Then we are going to have a pulley, frictionless pulley at this given point. Then we have a string. We are going to have a string which is going to run from this particular point. Then we can decide to use a light gate, of course, but in this case, let me just say we can be able to use the light gate to determine the speed at which it passes. Yeah, so let me just give the steps. Yeah, so place slotted, masses on the mass holder, place the slotted masses on the mass holder, and also we need to mark the starting point and the end point. Yeah, for instance, we can say let this be our starting point, start, and then we have end point somewhere here. Then you're going to use a meter rule in order to measure the length or the distance. You're going to use a meter rule to measure the distance between this starting point and the end point, so that you can be able to determine how long for each amount of force that you are going to add, or amount of mass you are going to be adding here, is going to pull this trolley down. Yeah, so we're going to say mark the starting and end point. End point on the runway. Yeah. Next, we are going to use a stopwatch to measure how long the trolley takes to cover the distance. And in that case, we are going to say then you can be able to work out speed is going to be distance over time, and also you can be able to work out acceleration is equals to change in velocity over change in time. So you need to remember that force is equals to mass times acceleration of our acceleration of is affected by the force acting on it. So we are going to now work out acceleration. So acceleration is change in v over t. So once you have worked out the speed, you have gotten the speed, you can be able to work out acceleration, and then we end up having force, and then we have corresponding acceleration in meters per second square. So which means that if you have the force and then you have the acceleration for different forces, then you can be able to compare how it affects each other. And then you need to remember that for you to work out the force, since we are talking about the slot masses at this given point, we'll say force is going to be equals to weight, and weight is equals to mass times gravity. So that is how we are going to work out the force added here in the slot masses. All right, great. So thank you guys for joining our lives. I would like to take you through this paper. Schooner, stop watching. And light gates, yes, we can be able to use a timer, we can be able to use a timer, we can be able to use light gates. Schooner, thank you for your message, that's correct. All right, great. Thank you guys. Cloud capture, thank you so much. Welcome to our live. And guys, please let me take this chance, request you, I'm taking this chance to request you to guys, please take this chance to like the live. Just like the live. Yeah, just like the live. I'm just requesting you to like the live so that I can be able to know that you are enjoying. Just I'm giving you a second for you to like the live so that we can be able to proceed to the next part. Basically, if you can look at this paper that we are having here, just giving us a picture on how questions are usually asked, and then we are going to see how you are supposed to approach it. So mine is to take you through so that when it comes on Monday, when you're going to do the paper, you'll be able to apply that. So whatever experiment we have described here is one of the required experiments, is among the required experiments you should know in AQA physics, All right, so let's move to the next part. Let's move to the next area so that we can be able to see what are the other questions that have been asked and how you are supposed to answer them. For those who are joining us already, we have this is a Trilogy. We have already discussed about the concept of electromagnetic waves, you need to remember the most important part that you need to remember is the wave equation, which is frequency times wavelength. Speed equals to frequency times wavelength. And also you need to remember different properties of waves like refraction, diffraction, and this is basically dispersion of light, because every type of wave, it has got a refractive index as it's passed through the material. We need also to remember under electromagnetic waves, you need to remember the order in which they are. Like for instance, here we have radio waves, we have microwaves, infrared, visible light, ultraviolet, we have X-rays at this point, and gamma rays. Then you need to understand similarities and differences. Differences is in terms of wavelength and frequency. I've mentioned that. So before tomorrow also, you need to remember what are the uses of each of the electromagnetic waves, and also you need to remember the harmful effects and dangers of these particular waves. All right, so under the required experiments, this one of the experiments you really need to know how to work out. All right, so we are told that the table shows the resultant force of the similar investigation, and in this investigation we have the resultant force as 1.2 newtons, and then we have the acceleration at this given point. Acceleration is identified as what? Acceleration is identified as 1.6. yeah, so we are expected to which Newton's law predicts acceleration is proportional to the force. This is Newton's second law. This is Newton's second law. First law is the law of inertia. Where an object will continue in its state of motion, or an object will continue in state of rest unless there is an external force acting on it. So basically you need to understand what each of the law represent. Then we have the third law. The third law is for every action force there's equal and opposite reaction. Action and reaction forces. So this is what Newton's third law of motion entails. For second law, that's the law that says force is equal to what? Ma. In that, which means that acceleration is directly proportional to the force applied, meaning that if you apply a force on an object, that object is going to accelerate, right? Yeah, so that is going to be fine. Yes, cloud capture. Do you do private lessons? Yes, I do. I do cloud capture. If you are in need, let me know. So that we can be able to make an arrangement on that. Cloud capture, yes, I do. I usually, there's some students, I have some students from the UK. I also have some students from Qatar who I usually do private tutoring. Yeah, all right. So let me know in the chat section if you need private classes, so that I can be able to share my personal email so that you can be able to reach me out. Yeah, just write in the chat section so that I can be able to share the personal email on that. Okay, so let's move to the next part. Determine the acceleration of the trolley. We have already said that for you to work out acceleration, we're going to use the formula force is equals to ma, isn't it? That's the formula we shall use, right? Then if we want to find acceleration, we're going to say acceleration is force over mass, which means that you can be able to find acceleration by substituting what we have here, because we are given the force as 1.2 and the acceleration is this. Acceleration is that. Oh, okay. What are we asked? Acceleration. Determine the acceleration of the trolley when the resultant force is this. Let's see. if there is any information that is provided, we have the force is given as what? 3.6. Determine the acceleration of the trolley when the resultant force is 3.6. So what is the resultant force? Yeah. So what is the acceleration? So we are going to say acceleration is equal to force, which is 3.6 divided by 1.2. And if you put it in the calculator, we are going to say that this is going to be what? Okay, so let's say, okay, from the information that was provided in this previous question, let's see, this is 1.2, 1.6. Yeah, so from this previous information that was provided here, that part was meant to enable us to know the mass of this trolley. So we are going to say mass is equals to force over acceleration. So if you take the mass, or if you take the force divided by acceleration, then we are going to do that. Yes, please. All right, yeah, so guys, can you please work out the acceleration? Cloud capture. I'm writing my email. My email is yes, cloud capture. You can take my email. I've just posted there, nick.moses8919@gmail.com. Yeah, so that's my email. Just write in the, just go and just type and say cloud capture. I'll be able to give you my personal contact so that we can be able to have a chat. All right, let's just proceed to the next part. So in this case, if we work out the mass, we need to know the mass of the trolley. This is going to be 1.2 over 1.6. If you work it out, you're going to get 0.75 kilograms. This is the mass of the trolley. From this information that is provided here, we were supposed to use it in order to work out the mass. Yeah. Now, after working out the mass, we can be able now to go down here and say, therefore, our acceleration is going to be what? Is going to be our mass, our force, which is 3.6. Then we divide that by 0.75, so that we can be able to put it in our calculator. 0.6 divided by 0.75. Cloud capture, confirm if you have taken that email, you have gotten your that email. Yeah, just confirm if you have gotten that email. Yeah, just confirm if you have gotten the email. Just confirm if you have gotten it. Yeah, so if we work it out, we are going to get our final answer is 4.8 meter per second square as the acceleration of this trolley. That's exactly what we are going to get as our answer, guys. All right, great capture. Crowd capture, crowd, thank you. I've seen your response. just write just an email your capture, cloud capture, then I'll be able to give you my personal contacts. We chat from there. All right, guys, let's proceed. And get to see what's happening down here. The next question, write down the equation that links acceleration, mass, and resultant force. Already we've written that equation some areas above, so we're going to say force resultant force is equals to mass times acceleration. Yeah, mass times acceleration. So that is the famous force is equals to ma, famously known as force is equals to ma. And we have said that this is what? In Newton's second law of motion. Newton's second law of motion. All right. Next, we are told the resultant force of 0.42 newtons act on a different trolley, and the acceleration is this. Calculate the mass of the trolley. So basically, we have already done this. So we're going to say mass times acceleration is equals to force. So if you don't want to rearrange this formula, what are you going to do, guys? Yeah, what are you going to do? You are going to substitute everything that is in the equation, and then this is going to be 0.42 is equals to the mass, which we don't know, times 1.2. Then at that given point, because this is going to reduce to 0.42 is equals to 1.2 m, then we can divide both sides by 1.2, divide by 1.2. You undo the multiplication, and then we are going to have this guy and this guy cancelling out. And if you work it out, you have 0.42, divide that by 1.2, we are going to get our answer equivalent to 0.35. 0.35 as the mass, of this particular object. And I need to say that if you are new to ProfLearn YouTube channel, guys, please like the live, leave a comment if you are benefiting something, and let me get to know whether you are ready for tomorrow's paper. Guys, I wish you all the best. And please, if you have not joined our Patreon page, where I usually add the PDF at the end of our video, I'm going to upload the PDF of this paper that we are having here in our Patreon page. So I'm requesting you, sir, if you have not joined our Patreon page, use the link in the description so that you can be able to become a member, so that you can be able to join us, guys. Yeah, so let's proceed and move to the next part. The next question here, a teacher uses ripple tank to demonstrate water waves. Something that we need to remember is that water waves are transverse waves. Yeah, they are transverse waves, and they are mechanical waves because they require medium for transmission. The teacher uses the lamp to project the shadow of the water waves onto the screen as shown there. The figure represents shadow of the water waves seen on the screen. 1.0 millimeters on the figure represents 5.0 millimeters on the screen. Yeah, so determine the accurate value of the wavelength of the wave. So basically what you're going to do in this question, a wavelength is the distance between two successive crests or troughs. So in this case, this is a crest and this is also a crest. So this is our wavelength. So what you are going to do in this case, you are going to take a ruler. You are going to take a ruler and measure. Yeah, you are going to take a ruler and then you are going to measure the length of that particular Yeah, you are going to take a ruler and then you are going to measure the length of that particular what? That particular distance that we are having here. So I want you to do it. Personally, I cannot be really managed to do it. I'm trying to see how can I be able to demonstrate measuring. Let me just see whether I can be able to get a ruler, and then I can be able to demonstrate how we can be able to measure that length. Yeah, in ProfLearn everything is possible, so we can be able to manage it. Let me just get a ruler quickly so that I can be able to add it here. We get to measure that length there. Almost getting my ruler. Almost there. Just be patient with me, guys. Yeah, just be patient with me. Yeah, so I'm just assuming that this is our ruler that we have here, so that we can be able to apply that concept. I'm just showing you how you can be able to measure. Now assume this is a ruler which you have. In order to measure, you are going to place it in such a way the 0 mark is going to coincide with that particular point that we have there. Then you are going to read how long is that. Some guys are saying that it's not visible. Yeah, some guys are saying it's not visible. Let me check if I can be able to use a different one. Yeah, so let me check how I can be able to use a different one. Yeah, it's not visible. Let me just use a different guys, so that we can be able to see how you can be able to take that measurements. Yeah, so we have our ruler well stipulated here, and let me just erase this. Our new ruler is this one. So we are going to measure the distance between those. We are going to place it like that. The distance between two circles. So for instance, if you get the distance is if we can say if the distance is, yeah, if you measure the distance and you get a given value, what I'm saying is that you are going to say 5 times the distance that you are going to get. This distance you are going to get here, the distance between two successive crests, times 5. Then you are supposed to determine the wavelength accurately, and accurately will mean that you have to take more measurements and then get the average. That's how you are going to get the most accurate value. So you can be able to do repeats. You can do repeats and find average. That has to be seen in the process of working out this particular question in this case. Guys, please I'm requesting, guys, if you can be able to like the live. If you are here, just take a second to like this live, and also share this live to your friends. Encourage them to join us so that we can be able to learn together. Yeah, so capture cloud, I believe you are following. Yeah, I believe you are following. Capture cloud, I believe you are following. Yeah, I've seen your message. I've seen your message, guys. Capture crowd. Yes, I'm just reply. Check your mail. Check your mail. Yeah, check your mail. I'm just sharing. Yeah. All right, I've replied to you. Let's proceed. That's the next part. So we are told the teacher adjusted the frequency of the wave produced by the ripple tank, and the teacher measured the wavelength 5 times. Calculate the value of x. Calculate the value of x. Yes, so we are told that the mean is 97. So in order to find the value of x, we are going to say this is 96 plus 99 plus 97 plus x plus 97. Then we divide everything by how many trials? 1 to 5. So there are 5 of them, and that is going to give us a mean of 97. So basically we are going to add this together. 96 plus 99 plus 97 plus 97. This is going to give us 389. 389 plus x over 5 is equals to 97. So which means that if we multiply that 5 times 97, 5 times 97, we are going to get 485. So this means 389 plus x is equals to 485. Therefore, if we want x, it's going to be 485. We subtract 389. If you work it out, what does it give you? Yeah, what's the value of x? Let's write in the chat section. What value of x are you getting after working it out? Guys, just write in the chat section, what value of x are you getting after working it out? Working it out, we are going to get a value of what? Of 96. So 96 is the value of x in this case. So that is exactly what this value is. Yeah, the teacher says the results are very precise. Which of the following support the statement? What does precision mean? Precise means the values are very, very close to each other. Yeah, right? The precision means the values are very close to each other, and they have they spread around. Yeah, they are not far from each other, which means they are very close to the mean. All the spread from the mean is very small. Precision, when you take measurements and you find they are precise, they may not be accurate, but they are precise. Why? The readings that you are taking are close. For instance, if you are having a reading as 1.2, 1.1, 1.3, these values are precise because they are very close to each other. But if you are having 1.2, 1.7, 1.9, they are not precise because the values are quite far from each other. So we are going to say the mean is very close to the true values. No, when it's close to the true value, it means it's accurate. Yeah, how close values are to the true value, we talk of accuracy. But precision has nothing to do with accuracy. It's how close the measurements that are taken are. So we can be able to say the spread of values about the mean is very small. This is what is going to be the correct answer in this case, and that's going to be that. So we shall put a tick at that given point. Yeah, so basically that's what we're describe the difference between longitudinal waves and transverse waves. So you need to understand we have light waves. Light waves are transverse waves, and then we have sound waves which are longitudinal. So we are going to say difference longitudinal waves. So let's just start it in a better way. In longitudinal waves, in longitudinal waves, particles vibrate parallel to the wave direction. While in transverse waves, particles vibrate perpendicular to the wave direction. Yeah, so those waves which have crests and troughs, they are called transverse waves. They have crests and they have what? Troughs. And the distance between a crest and another crest, that is a wavelength, and this height here represents the amplitude. But when we are talking about transverse longitudinal waves, we have rarefactions, we have compressions, and this point where the waves are spread out, that is rarefactions, which is the regions which is also termed as regions of low pressure. Regions of low pressure. Yeah, so basically that is exactly what we're going to do. Journey to grade 9s. Journey to grade 9s. All the best. All the best. Journey to grade 9. And I really wish all the guys who are in this live journey to grade 9, because we are having journey to grade 9s joining us. Also, I wish you the journey. May the journey to grade 9 be successful. All right, guys, please just take this chance to like the live, and also leave a comment whether you are enjoying the live. Yeah, just leave a comment, let me know whether you are enjoying the live. Guys, welcome to the live. Welcome all. Please take this chance to share and also like the live. Yeah, as we continue learning, please show support to ProfLearn. Show support to ProfLearn as we are continuing with our journey to grade 9. All right, so moving further, we have next question down here. Let's check what the question was about. The next question, this is about motor effect. What is motor effect? When there is a current in a conductor, and that conductor is placed within a magnetic field. So for instance here, if you can look at the diagram we're having here, whatever we have is basically a permanent magnet. Yeah, so we are having a permanent magnet in this case, and this permanent magnet has got magnetic fields. The magnetic fields are usually pointing from the north to the south. But if you can notice, current is going to flow in this direction. It will flow that way. Then in our conductor, current will be flowing in this direction, right? Yeah. So this conductor is going to undergo, it's going to experience a force, because when current flows through this conductor, then there will be magnetic fields which will be created around the conductor. Yeah, there will be magnetic fields which are going to be created around the conductor. And if you want to predict the direction of motion of this, you see, if you look at the diagram, the current is approaching us, so my thumb will approach me. I want you to try doing it. Your finger should assume you are holding that copper rod, and then this thumb will point towards you, so that you can be able to, the thumb usually, for right hand grip rule, the thumb usually points to the direction of the current. Yeah, so these fingers will tell you the direction of the fields. So which means our fields in around the conductor will point that way, on the other side will point up that way. So when current is flowing through this copper rod, there will be magnetic fields created around it. And also you can see we have magnetic fields from the permanent magnet. When these two magnetic fields are going to interact, this copper rod is going to experience a force. And for you to predict the direction of the force, you are going to use Fleming's left hand rule. We are going to use Fleming's left hand rule. We are going to hold the first finger, second finger, and the thumb in such a way they are 90 degrees. They are at right angles to each other, like that. Then since the first finger is the one that directs fields, then I'm going to point it downward, and this is current. This is going to point towards me. This finger here is going to point towards me because the current is coming this side, so I'll be able to place it this way. Then this thumb is going to give me the direction in which the motion is going to. So the copper rod is going to experience a force in that particular direction. Let me just draw it there. It's going to experience a force in that direction. Yeah, so this is the force which the copper rod is going to experience using Fleming's left hand rule. Now the copper rod remains stationary while the switch is open. Because it will remain stationary because there is no what? There is no electric current flowing. But the tendency of the object remaining stationary is called inertia. Already I had mentioned that. I had mentioned the law of inertia in the beginning, which is the first law, which we shall say this is what? Inertia. The law of inertia. So an object will tend to remain in its state of rest or in its state of motion, provided there is no external force that is acting on it. Yeah. So that is the first thing that the first question you are supposed to identify at that point. Then the next question that was asked here, yeah, the next question that is asked at this given point, let's see the next question that is asked here. Yeah, in which direction will the copper rod accelerate? The copper rod, of course, we have said is going to accelerate in this direction. I've already indicated that in the diagram, and then we're going to say that's going to be the particular direction it's going to follow there. Explain one way the teacher could increase the acceleration of the rod. Now we are going to look at how is the teacher going to increase the force. Acceleration is going to depend on the amount of force experienced. And now in this case, we are going to say increasing the current, increasing the amount of what? Current is going to increase the acceleration there. So we are going to say let me just go down there so that we can be able to have it written down. increasing the current will increase the resultant force. And increasing the resultant force, you know, force is equals to mass times acceleration. So which means acceleration is a force over mass. Mass of the rod is going to remain the same. So if you increase the current, you are just increasing what? The force. And if you manage to increase the force, from this relation you can see here, acceleration is going to increase, because acceleration is directly proportional to the amount of force. We have the next question, and this next question talks about a magnet. The magnet is used to demonstrate in a demonstration. The magnet is used in the demonstration was a permanent magnet. We have an iron bar, and then we have a permanent magnet. Describe how the permanent magnet could be used to test if the iron bar is also a permanent magnet. How can you be able to demonstrate that? How are we going to demonstrate that? The surest way, let me just mention here, the surest way you can be able to use in order to test whether a material is a magnet is through repulsion. Because for a magnet can attract both a magnet and also can attract a magnetic material, right? So the best way to test, this is what we're going to do. We're going to say test if the permanent magnet can attract or can attract and repel. Can attract one end of the iron bar and also repel the other end of the iron bar. So the surest way you can be able to test whether a material is magnetic or not is by use of what? By the use of repulsion. Because if it's just attraction, it can occur for unlike poles, and also attraction can occur for for magnetic materials. So the best way to check whether that is true, guys, is to ensure that there is repulsion in one end. So if one end is repelled, then it means that this is what? Those are like poles. Yeah, so guys, if you are joining us, please, I can see we are joining already. Please guys, can you please just like the live? Take a second to like the live and just leave a comment if you are learning and you are benefiting from this particular live. You are learning something from the live. Explain how the magnetic compass provide evidence that the earth is magnetic. How does it provide evidence? Yeah, the earth is magnetic, because if you just let the compass to lie flat, it's going to point in a particular direction. Yeah, so if you place a compass in a given position, it's going to rotate and it's going to point in a particular compass, a direction. So we're going to say that the compass needle always points in the same direction. Always points in the same direction. Because it aligns itself to the Earth's magnetic field, to the Earth's magnetic fields. Earth's magnetic field. Yeah, so basically that's what we are going to say. And then now we are going to move to question number 5, guys. Question number 5. We are moving to question number 5. We are told that the figure shows a garden chair hanging from a spring. There is a guy here who is having good time and relaxing on the chair as he's swinging. And then which of the following describe the relation between weight acting on the spring and extension? So meaning we are going to use the relationship Hooke's law, which is what? Force is equals to Ke. Yeah, Ke. And that's going to be weight is equals to what? Ke. Which we can say that weight is directly proportional to extension. Weight is directly proportional to extension, whereby K is the constant of proportionality in that case. Yeah, the spring constant. So we can be able to say our answer in that case is going to be weight is directly proportional to the extension. So which means that as the weight increases, the extension of the spring also increases. How much the spring is going to stretch. The person has a weight of 750 newtons. The person's weight causes the spring to extend by these millimeters. Then calculate the spring constant, and then you have to come and check here in which unit is the spring constant given in meters. So meaning that for you to work out the question, then you have to ensure that the extension also is in meters. So which means that we're going to say that extension is going to be 60 divided by 1000. So if you work it out, you're going to get this as 0.6 meters. Then we can be able to say weight, force, and the force is going to be the weight of this person. The force is going to be equal to the weight of this person. So which means we are going to use this relationship in order to work out the spring constant of this particular spring. Don't forget that in order to work out spring constant, K, it's going to be force over extension, and that is going to translate to what? 750 divided by 0.06 meters, and this is newtons. So if you just divide here, 750 divided by 0.306, this is going to be 1.25 times 10 raised to power 1, 2, 3, 4 times 10 raised to power 4 as the answer in that case. Or you can even just write direct 12500 Newton per meter. Yeah, so meaning that for every 1 meter, this spring require a force of that. Yeah, so that we can be able to do that. Now, yeah, so I can, guys, feel so much welcome to our live. Yeah, I think I swear he said hello to the rest. Yeah, so I think so. I swear he said hello to the rest. ProfLearn. Guys, please guys, thank you for joining the live. Thank you for joining the live. Thank you for joining the live. I don't know whether Cloud is here. Cloud, are you there? Cloud Capture, are you here? Let me get to know. I got so much held up. Cloud, are you there? Cloud Capture. Okay, all right. Ibs. No, sir, he left. Okay, fine, no problem. No worries. All right, guys, we are continuing to the next part of the question. Just continuing. All right, so yeah, I've realized there's some guys who will call themselves ProfLearn here. That's not the right thing to do. Let's be respectful, because all the students who are here are just have just come here to learn. So I don't entertain that. Yeah, so basically that's what we are supposed to do. The manufacturer of the chair tests a new spring to see if it is suitable to hang the chair. The spring can store a maximum of 1,800 joules of electric potential energy before it becomes inelastic deformed. Yeah, inelastic deformed. What's defined by inelastic deformed? What does it mean by the term inelastic deformation? What does that mean? Yeah, so this means, yeah, we are going to say an object is said to be inelastically deformed if it cannot return to the original shape and size. It cannot return to the original size and shape once the force is removed. And that is what we mean by inelastic deformation. An object is going to be elastically deformed if once the force has been removed, it's not going to return to the original size and shape. Yeah. Next question that follows is calculate the maximum extension before the spring becomes inelastically deformed. So the first thing that we need to understand, how do we calculate elastic potential energy of materials? We're going to say elastic potential energy is going to be a half kx squared. Yeah, or we can be able to say a half k e squared, where e, this is elastic potential energy, this is the spring constant, and e is the extension. So which means that we can say this is 1,800 is equals to a half times the spring constant is given here, 225 times e squared. So if we make e the subject, e squared the subject of the formula, I need to rearrange this and make e the subject of the formula. This is going to be 1,800 times 2 over 225, like that, which we are going to put in our calculator in order to get the answer. So this is exactly what we are going to put in our calculator. We shall put it in our calculator. We're going to say that let's put it in our calculator and see what we shall have. Let me clear everything. So we are going to say this is going to be square root. Let me clear everything. Square root. Then we put the fraction there. And this is going to be 1,800, which is multiplied to 2 and the denominator we have 225. So if you press the equal sign, we're going to get our answer equivalent to 4. So we're going to say our answer is basically 4. Yeah, so our answer is 4 here. Yeah, and then we need to say this is in which units? In meters. So we are going to transfer it down here just to make the examiner happy. Yeah. Evaluate the suitability of the new spring. How do we evaluate the suitability of the new spring in this particular case? How are we going to assess the suitability of the new spring? We are told evaluate the suitability of the new spring on the hang of the chair. Maximum elastic potential energy is 1800 joules. The spring constant is that, and the weight of the person is 750. The distance between the bottom of the chair and the ground is 30 centimeters. Calculate the include calculations of your particular answer in this particular case. In order to earn our marks, we have to ensure that we are going to include our answers there. So the first thing that we need to do here is to work out the extension of this particular spring that we have. We are going to work out the extension, and this is going to be what? This is going to be extension is going to be equals to 750 divided by 225. If you work it out, what do you get? 750 divided by 225. This is going to translate to 3.3 meters. So if you are having 3.3 meters, the extension would be too great, and which means that by the time you sit on that chair, this person is going to hit the ground. Yeah, it's going to hit the ground. So which means that that's not suitable. Yeah, the spring is not going to be suitable in that case. It's not going to be suitable at all. This spring is not suitable. Yeah, because the extension will be too much, and this person will sit on the floor instead. Yeah, the person will sit on the floor instead. So they have to ensure they use a spring which has a greater spring constant, a larger spring constant, so that it can be able to withstand the force without stretching more. Guys, please consider liking the live, and also leave a comment the chat section. All right, so we need to move to the next part. So what you are supposed to do in this question is to work out the extension, and in order to work out the extension, this is the formula to use, and then we check the suitability because the extension is too long. To be withstood. Then we have question number 6, and question 6 saying a child is dropping a stone into the water. Yeah, so this is a kind of a bridge. We can see a bridge here, and the stone is going to fall through that height. When the child dropped the stone, it passes through the child's feet at a velocity of 3.1 meters per second. The child's feet is 6.3 meters above the water. The child's feet is basically from this point to this point, we are told is 6.3. The height there is basically 6.3 meters, and the initial velocity at this point when the stone was passing the child's feet is 3.1 meters per second. Yeah, we are taking gravity to be this value, and then we are supposed to calculate the velocity with which the stone is going to hit the water. So we are supposed to calculate the velocity with which this stone is going to hit this water. So what are we going to do in this case? We are going to use the equations of what? We're going to use the equations of motion, and therefore we are going to say that v squared is equals to u squared plus 2as, and our s is the displacement that we have at that point. So final velocity, v squared is final velocity, so we shall say v squared is equals to 3.1 squared plus 2 times 9.8 times 9.8 times the displacement, which is 3.1. So if you work it out, you're going to say 3.1 squared we can be able to work that in our calculator. We can be able to say, in order to work out this out, this is going to be what? We clear everything, so this is going to be v is going to be square root of 3.1 squared plus 2 times 9.8 times 3.1. Now we can put it in the calculator. Square root 3.1 squared plus 2 times 9.8. We multiply that to, all right, this is 6.3. S is 6.3. I need to change this. I don't know why I'm writing that. This 6.3, that is the displacement. S is 6.3. Yes, 6.3. Was about to make a very big mistake, one-time mistake, and then this is going to be 6.3. So if you work it out, you're gonna get your answer equivalent to 11.5. So we are going to get this is 11.5. So we can be able to say this is 11.5 meters per second, which is approximately 12 meters per second. Now we were told the accuracy at which we are with which we are going to leave our answer, so we are going to stick to that, and this is going to be 12 meters per second. Basically that's what we are going to do in order to get that mark there. That is what we are expected to do in order to work this out. Yeah, so we need to focus and continue with the next part. The velocity is a vector quantity. Describe the velocity of the stone as it falls through air. Assume there is no air resistance. Velocity is a vector quantity, so it has both direction and magnitude. So we are going to say that the magnitude of the velocity increases uniformly and direction remains constant as the stone as constant as it falls. Yeah, it remains constant as it falls, because we are told that there's no air resistance, so we are going to assume air resistance in that case, but the direction is going to be downwards throughout. The figure shows the stone just after it enters the water. The velocity is acting that direction. As the stone moves through the water, the stone slows constantly. Explain why. Yeah, upward force, because there is a resultant upward force. There is a resultant force acting on this particular stone. So that is exactly what's going to happen here. So it's going to slow down, slows down, because water resistance we are saying water resistance or drag is greater than the weight of the stone. The weight of the stone. So there are different forces that are acting here. The weight of the stone is acting downwards. We have water resistance or drag acting upwards, and also we have what we call upthrust force acting upward. So different forces are having a share of exactly what's happening in this case. So the upward forces are greater than the downward force, and then in that case the stone is going to experience a resultant force upward. Yeah, so the resultant force will be acting upwards, so will be acting upwards. And when resultant force is acting upwards, so we are going to say, so the velocity of the stone decreases, which also decreases drag force. Remember, drag or air resistance depends on the speed at which the object is moving. So that's why I'm saying if there is an upward force acting an upward resultant force, the velocity is going to decrease, and also drag is going to decrease. Yeah, right. Yeah, so basically that's what you are supposed to mention in this particular question. Guys, if you have joined us, please guys, kindly make more like support. Yeah, guys, please just write in the comment section, and also leave a comment in our chat section. Yeah, leave a comment in the chat section, like the live. All right, so moving on to the next question. The next question is talking about a velocity time graph. Determine the acceleration of the car. Determine the deceleration of the car. Where is the car decelerating? It's in this region here. Yeah, this is where deceleration is taking place. And something that you need to remember, whenever you are talking about acceleration from a velocity time graph, you have to look at the gradient. We are going to find the gradient, or we can even say if final velocity for this car is going to be 0, and then we can say acceleration is equal to final velocity minus initial velocity over time. Or you can say acceleration is equal to what? Gradient. You work out the gradient of the line. So in that case, I've decided to use this formula for acceleration in order to work it out. But remember, acceleration, initial velocity is this one, which is going to be read at this point, and the final velocity is the value that we're going to read here, and the time taken is going to be what? Yeah, that's going to be 5.12, 5.3. Then we can be able to say this is going to be 0 minus initial velocity was 26. Yeah, it was 26 there. Divide by time in seconds, 5.30. So if you work it out, what's your value going to be? Which is going to translate to around 4.9, which is going to translate to around negative 4.9. Yeah. No, the time, no. The time will be from this point to this point here. So what's the time taken? Yeah. So we are going to say minus 2. So that is going to be if you work it out, you are going to get your answer around 7.88. Yeah, 7.88, which is going to be 8 meter per second square, because we are talking about acceleration. So that is how you're going to do it. So you have to ensure you are using the time from this point here to this particular point. So that is exactly what we are going to do. Our time is going to be 5.3 minus 2, and then we work it out. Any question up to that point? Let me get to know if there's any question up to this point so far. If there's any question, let me get to know if there's any question up to this point here. Any question? Let me get to know if there's any question up to the area that we have discussed. Are you getting value from this particular tutorial? All right, so the driver of the car has a reaction time of 0.75. Determine the stopping distance. Stopping distance is the distance, yeah, from when the brakes are applied to when the car stops. Yeah. So which is going to be calculated, then we're going to work it out. Stopping distance and of the car. So what we need to remember is that stopping distance is equals to thinking distance plus braking distance. Yeah, so it's going to be thinking distance plus the braking distance. So which means thinking distance is going to be calculated from distance times time, speed times time rather. Speed, which was 26, times the reaction time, which was 0.75. So that's going to be what, if you work it out, which is 19.5 meters. 19.5 meters is our thinking distance. So we need also to work out braking distance. Braking distance is going to be what? Braking distance is going to be 26 minus 0 over 2, and that is going to translate to 42. Yeah, this is squared, right? Yeah, and then times what? 2 times 8.0, and this is going to be a total of distance of total braking distance. If we work it out, is going to be 42.25, 42.25, and then we shall now have stopping distance. And our stopping distance will be adding the two, 19.5 plus 42.25, which is going to translate to 61.75. So most important thing that you need to remember in these concepts, all in this area, is that stopping distance is basically thinking distance. Stopping distance is basically thinking distance, and thinking distance is the distance covered by the car while the driver is thinking what to do, and braking distance is the distance covered by the car while the driver, from when the driver applies the brake to when the car comes to a complete stop. Factors that affect thinking distance include drugs, poor visibility, yeah, can also include of the age, but braking distance is affected by the conditions of the road, conditions of the tire, speed at which the car is also moving. So basically that's what we are going to talk about. Explain why large deceleration may be dangerous, because a car may skid even when brakes are applied. So it will be very difficult, and this can be able to cause an accident. Yeah, can also lead to overheating when brakes are applied. Yeah, so I'll applied. Yeah, applied. Yeah, it may cause overheating, and also the forces greater deceleration will cause a greater force, and this greater force can also cause an accident. So basically this is what you are supposed to do, and as far as AQA physics is concerned, all these questions that we have discussed here is to enable you to understand how you are supposed to answer different questions. And if you are new to ProfLearn YouTube channel, yeah, Fire Legend, I'm still a bit confused. Fire Legend, which area are you confused? Fire Legend, let me get to know which area are you confused. This is AQA physics paper 2H. Let me know which area you are confused, so that I can be able to do a clarification on that particular area. Fire Legend, before I end the live, 7.3, confused in the area of 7.3. Okay, Fire Legend, let me just reply on that. Yeah, explain why the large deceleration will be dangerous. What will be the reasons why it will be dangerous? Because if you apply a large deceleration, the brakes may overheat. Yeah, also the car may skid. We can also say there will be a greater force, because we know force is equals to what? Mass times acceleration. So even if it's a deceleration, there will be a greater force exerted on even the car occupants, because it will be decelerating at a very larger rate. So greater force, which can lead to injury. So these are different aspects that we're gonna mention at that given point. So guys, we were having a walkthrough of questions that you need to prepare on, how to answer different questions as far as AQA physics is concerned. And this paper that we have done here is AQA paper of June 2023. So that is Trilogy paper, combined science. We have discussed different aspects, and the topics that were prominent here is electromagnetic waves, where we talked of the way the waves are arranged. You need to understand the order of the waves. You need to understand that waves on this end have low frequency but long wavelength. They have long wavelength, but here they have short wavelength. Yeah, so you need to understand common properties between the waves in the electromagnetic waves. Then you need to understand differences in that case, and that you need also to know the formula for the wave equation, and this is the formula that you shall be asked various questions on how to use it. So you need to be prepared to answer question to as far as the wave equation is concerned. We went ahead also to talk about expected or the required experiment, and we have described how you can be able to show the relationship between the force and the acceleration of the trolley, because we said we are going to add slotted masses here, and the masses will be adding the weight and will provide a force that will pull the trolley down. So as we keep on increasing the force, we'll be able to detect or check at what speed, at what would be the acceleration of the trolley down the runway. The next topic was force equals to mass times acceleration, and there was the concept of waves. Yeah, there was the topic of waves which we discussed. We talked about longitudinal and transverse waves. We talked about motor effect, and we said that when current passes through a conductor, yeah, then there will be what? A force experienced in that conductor, because around the conductor there will be a magnetic field. Yeah, so basically those are the areas we discussed in this particular paper. I wish you guys all the best. Also, Hooke's law was there. I wish you good luck. I wish you good luck, guys. I wish you all the best. Tomorrow's paper, I wish you all the best. See you guys. Great guys. I wish you the best. Good luck to all of you. Yes, the Deg, I'm a Kenyan. I'm from Kenya. Deg Flu, where are you from? Which country? Yeah, I wish you all the best, guys. Let's write in the comment section. We are ready. Let's write in the comment section. We are ready for the paper. Oh, from Kenya as well. Great, 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 Deg. I'm in Kenya, Mombasa. Yeah, guys, all the best. This is S. S is from Nigeria. Good luck. S saying, I'm ready. Right. Good luck to all of you guys. Bye. Bye, guys. Fire Legend. Bye. Great. Have a good evening. Nice time. Bye. Bye. S100. Bye. Guys, as we are leaving, please let's like the live as we leave. If you have not liked the live, just like the live, guys. As we are leaving, let's like the live. And all the best in tomorrow's paper. Natoka wapi? Where you coming from? Where you coming from? Where you coming from?
Buying something. Naja, auntie.